Right, for our final online lesson, we're going to look at standard form, which is something that you would have met probably back in year 9, and not only in maths, but you would have met this in your science lessons, because the use of standard form is to allow scientists, mathematicians to write very, very large numbers and very, very small numbers in a very efficient way, because no matter how large or small the number is, no matter how many zeros it may contain, it doesn't matter. The format will always be a number between 1 and 10 multiplied by a power of 10. And the best way to go about thinking about how to deal with numbers in standard form is to go right the way back to primary school, when you were first met hundreds, tens and units. So when you were first introduced to place value in the number system. And if we work first of all to the left of the decimal point, you know that your units is 1, tens, hundreds, and so on. But we can now write these as powers of 10. We discovered yesterday when we were looking at powers that anything to the power of 0 is 1. So I can write the units column as 10 to the power of 0. We also looked yesterday when we were working with indices that if I just have the number 10, that's the same as having it to the power of 1. So any number to the power of 1 is just itself. If I'm looking at the value of 100, well, I know 100 is 10 squared. And what I would suggest is, if you can't remember the units is 10 to the 0, you'll always remember that 100 is 10 squared. So if you write that one in first, and then you know you're going to count down the powers from there, and in this direction you're going to count them upwards. So 10,000 would be 10 to the 4, 100,000 10 to the 5, million 10 to the 6, and so on. And the same thing applies to the right of the decimal point, where we're working with smaller numbers. Well, 1 over 10 to the 1, if you remember yesterday we were talking about reciprocals, and sorry, there's a tractor going up the road. The reciprocal you'd write to the negative power. So 1 over 10 is 10 to the negative 1. 1 over 100 would be 10 to the negative 2. 1 over 1,000, 10 to the negative 3. And the same increasing negative powers going forever onwards in that direction. And each of these then gives you the place value. So if we've got the number 35,000, then what we can do is, if we drop that into our grid here, and if I start at the right and work left, you can see that 35,000 is 3 10,000s and 5 thousands, and then 0 everything else. And what that actually means is that I can write this as a product. I could write this as, I've got 35,000 times 10 to the 0. Now 10 to the 0 is 1, and 35,000 times 1 is 35,000. Or, if I come to this column, I could write it as 3,500 times 10 to the power of 1. And I'd get the same number, the same numerical value out of it, because that's 3,500 times 10, which increases it by a power of 10. If I went here, I could write it as 350 times 10 to the power of 2. There I could write it as 35 times 10 to the 3, or I could write it as 3.5 times 10 to the 4. And while all of those forms of writing that number are numerically identical, if we go back to what I said about the format of standard form, it's writing number as a decimal number between 1 and 10 multiplied by a power of 10. So the standard form version is this bottom one, where I've got 3.5 times 10 to the power of 4. So if you're given a question where they ask you to write down what 35,000 is in standard form, all you need to do is very quickly write yourself out a grid like this, drop the digits into it. It doesn't have to be fancy like that. You know, we could just do it like this: 10 to the 0, 10 to the 1, 10 squared, 10 cubed, 10 to the 4. Maybe you need to go further, then drop your number underneath. And then what you do is you go to the biggest, the digit with the biggest place value, so it's 3. So it's going to be 3 times 10 to the 4, except it's not 3, it's 3.5, because it's got this part of it as well. Let's take a look at the next one. So the next one, so same thing, here's my grid: 10 to the 0, 10 to the 1, 10 squared, 10 cubed, 10 to the 4. Drop in my number, 0, 5, 7, 4. So this one is going to be 4 times 10 to the 3, but it's not 4 times 10 to the 3, it's between 4,000 and 5,000, so it's going to be 4.75 times 10 to the 3. So I'm looking for the column with the greatest place value, that's giving me the power, and then it'll be 4.75 times 10 to the 3. And the same thing applies when we're working with small numbers, except when we're working with small numbers, we're working this side of the decimal point, and we've got negative powers. So we've got 0.038. So the digit with the biggest place value is this one. That's a larger place value than that. Every time you go in this direction, you're getting progressively smaller. So it's going to be 3.8 times 10 to the minus 2. So just get your powers, your columns, your tens, units, tenths, drop the number in, and then read it off. It's as straightforward as that. So those 3 examples are where you're given numbers written in normal decimal form and you're turning them into standard form. The other skill that you need to have is to be able to go the other way, to be able to take a number that's given in standard form and write it as a normal decimal number. So same starting point here. We start with our grid, so we put in our tens, 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5. And what this is saying is we've got 5 lots of 10 to the 4. So here's my 10 to the 4, which is going in there. Now in order to maintain the value and the place position of that, I have to fill up all the gaps between that digit and the decimal point with zeros. So 5 times 10 to the power of 4 is 50,000. 5 followed by 4 zeros. Same with this one, except this time we've got a negative power. So minus 1, minus 2, minus 3, minus 4, minus 5. 2.34 times 10 to the negative 3. So the 2 is going in the negative 3 column, and then the rest of it trails off after that. In order to keep those digits there, I need to fill the columns between those digits and the decimal points with zeros. We tend not to write point, we tend to write 0 point, so we put a 0 that side as well. So that number is 0.00234. So intermediate tier GCSE, you need to be comfortable travelling in both directions, taking a decimal number and turning it into standard form, taking a standard form number, turning it back into decimal. Then we need to be able to deal on a non-calculator paper, so without a calculator, with performing arithmetic with standard form numbers as well. And what I'm talking about are multiplying, dividing, adding and subtraction. And there's two different approaches really. With addition and subtraction, it's the first one we're going to look at. What we need to do is to turn these back into decimal numbers, then perform the addition or subtraction, and then push them back again into standard form. So 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, and so on. So I got 2.79 times 10 to the 3. There's my 10 to the 3 column. Drop in the digits, fill in any spaces with a 0. So 2.79 times 10 to the 3 is 2,790. 4.31 times 10 to the 5, so the 4 is going in the 10 to the 5. So I got 4, 3, 1, 0, 0, 0. And I'm going to add these together. And when I do that, I get 0, 9, 7, 3, 3, 4. So that's going to be 4.3379 times 10 to the 5. But we want to give our answer to two significant figures. So when we round into two significant figures, the two most significant figures here are the 4 and that 3, because they're in the most powerful place value positions. So if I'm rounding that to two significant figures, all I need are the 4, and then we've got to decide whether the number is closer to 44000 or 43000. And just like with decimal places, we look at the next digit, it's less than 5, it's closer to 43000. So that's to two significant figures. Now I turn that into standard form. It's going to be 4 times 10 to the 5, but it's not 4 times 10 to the 5, it's 4.3 times 10 to the 5. So we've turned each number into a normal decimal number, then we've performed our addition, then we've gone to turn it back, but before we've done that, we've turned it into two significant figures and then put it into standard form. Same concept with subtraction. So 10 to the 0, minus 1, minus 2, minus 3, minus 4, minus 5. Put the number we've got in. It's 3.5 times 10 to the minus 1. So the 3 is going in the minus 1 column, and then I got the 5, and then I got zeros running in that direction, and I got a 0 there. And I'm subtracting from that 2.8 times 10 to the minus 3. So the 2 is going there, the 8, 0, and then I can match the zeros up to there. So this is a non-calculator subtraction. So the 0, 0, straightforward. Now here, I can't take 8 from 0, so I need to borrow. I can't take 8 from 0, so I've got to borrow. So that becomes a 4, that becomes a 10, that becomes a 9, that becomes a 10. So that's the way you were almost certainly taught to subtract without a calculator back in primary school. So I'll use that method as well. So I have 8 from 10 is 2, 2 from 9 is 7, 0 from 4 is 4, 3. So this number is 0.3472, but to two significant figures, these are the most significant. So 2SF, these are the two most significant, but the next digit is 5 or more, so this would become 0.35. So as a decimal number, it's 0.35 to two significant figures, and in standard form that's going to be 3 times 10 to the minus 1, but it's not 3 times 10 to the minus 1, it's 3.5 times 10 to the minus 1. So that's how you add and subtract. When it comes to multiplying and dividing, then we're going to apply the rules for indices that we looked at yesterday. And what we do is we separate out the numerical part of the standard form and the power, the 10, base 10 part of it. When we're multiplying those, remember from yesterday, it means that we can add the powers. So just to remind ourselves, when multiplying numbers of the same basis, we add the powers. So 10 to the 4 times 10 to the 5 is 10 to the 9. 10 to the minus 3 times 10 to the 7 is 10 to the 4. Minus 3 plus 7. When we divide, we subtract. So that's going to be 10 to the 9 minus 5 is 4. This one is going to be 10 to the 7 minus 3. That becomes a plus, so that's going to be 7 plus 3, which is 10 to the 10. So be careful when you're subtracting a negative index. And this one is going to be 10 to the minus 2 minus 5. The minus 2 is unaffected, but the minus becomes a plus. So we get 10 to the minus 2 add 5. So you're at negative 2 going up 5, you end up at plus 3. So that's just a refresher from what we were doing yesterday. Okay, so what we do to this is we change it so that we've got 2.4 times 3, and then we've got the times 10 to the minus 4 plus 7. So we can add those powers because they're both to the base 10. So we get that. 2.4 times 3, we can work that out separately. So let's just pop over here. 2.4 times 3. 3 4s are 12. 2 3s are 6 and 7. We need to decide where the decimal point goes. Well, if that was just 2 times 3, it would be 6. So it's not going to be 72, it's not going to be 0.72, it's going to be 7.2. So this becomes 7.2 times 10 minus 4 plus 7, 3. Same idea when we divide. For this one, I'm going to do 2.4 divided by 3, which is that part. And then with this, I'm going to do times 10 to the minus 4 subtract 7. Okay, because what we're doing is that's times 10 to the minus 4 times 10 to the 7. We're going to be dividing those, so we're going to subtract the powers. So I've got 2.4 divided by 3, so let's pop over here and deal with that. 3 into 2 doesn't go, carry it over. 3 into 24 goes 8 times. So what we end up with here is 0.8 times 10 to the minus 11. Now we've got a problem with that, and the problem is that this isn't in standard form because that's not between 1 and 10. So let's think about this. Let's imagine, rather than me have to write the whole thing out to negative 11, let's imagine what would happen if we had 0.8 times 10 to the minus, let's go 10 minus 3. So we've got 10 decimal point there, 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, 10 to the minus 4, and so on. If it was 1 times 10 to the minus 3, I'd have a 1 there. It's not 1 times 10 to the minus 3, it's less than that. So I'm going to have this. So 10 to the 0.8 times 10 to the minus 3 is the same as 8 times 10 to the minus 4. So that index is going to drop down one more. So this will be 8 times 10 to the minus 12, to put it into standard form. So if they're being really narky with this, that's the nasty trick that they'll drop in the bottom. You think your answer is 0.8 and you're not spotting, oh hang on, that's not between 1 and 10. So then one more to look at, which is the same as the one above, but it's just written in a different format. It's written as a fraction. But we're going to do 4.2 divided by 6 times 10 to the 4 minus 2. Let's bimble over here and do our 4.2 divided by 6. 6 into 4 doesn't go, carry 4. 6 into 42 goes 7 times. So this becomes 0.7 times 10 to the 6. 4 minus minus, that becomes a plus. And we get the same situation here where I haven't got a number between 1 and 10. So let's just, for the sake of practicing, let's check what we're going to do here. So this time I'm going this side of the decimal point. So I start with the unit, 10 to the 0, 10 to the 1, 10 squared, 10 cubed, 4, 5, 6, 7, and so on. Now if I had 1 times 10 to the 6, then it would be there. 1 times 10 to the 6 with a string of zeros. But I've got less than 1, I've got 0.7, so it would be 0 there and 7 there, followed by the zeros to hold it there. So 0.7 times 10 to the 6 is the same as 7 times 10 to the 5. That's not in standard form, that is. So in those 24 minutes we have covered everything you need to be able to deal with standard form. We've gone from being able to turn any number into standard form, and to go back there I got those lovely printed grids, but in reality you're not going to have those printed grids on an exam paper, you're just going to write them out like that and drop them in. And if there's no room where the question is, just use the back of the page, and that's fine. So we've gone from being able to turn normal numbers into standard form numbers into normal numbers. We've learned to add and subtract numbers without a calculator and give your answers in standard form, and multiply and divide numbers as well. So those are the skills that you now need to practice on the past paper slides file that I've shared with you. So you have a go at that. As usual, later on this evening I will post my solutions for you to have a comparison with. And then I really look forward to seeing you on Monday back in school. Have a great weekend, guys.